Okay, let me show you a magic trick. You see this mount here? It's a 3D printed mount. It's DIY. It's very low cost. It's pretty cool. I'll go into the details of the mount itself in a moment. But right now, it's in dire need of polar alignment. So let's see how I would do normally polar alignment. So I would normally go to Nina, which is what I have here. I would go to the imaging tab. I would go to what 3-point polar alignment, which is a free plugin for Nina. And then I would run 3-point polar alignment and then manually, mess with the controls on the mount. But let me show you what happens. So I'm going to click play here. And immediately there's this window that pops up and tells me that Nina has started polar alignment. Interesting. Indeed, we can see the mount is slewing. So let's wait for the mount to do its thing and get a few points for polar alignment. It's done the first slew. The mount is settling down. We're going to take an exposure. There's going to be some plate solving. Here we go. And now it's going to the third and final point. Nina gives a few errors. Let's not worry about it. We're taking the last image to solve. The image is solved and we get a result of 41 arc minutes, 39 arc minutes. And see what's happening here. Adjusting mount azimuth, altitude, what's going on? And we see weird star trails here. I haven't done anything. I'm not touching anything. My hands are here. I'm raising my hands. And yet suddenly it's better. It's not 13 arc minutes, 17 arc minutes. What is going on? So it seems to still be moving. We're going to take another exposure. Here we go. Now the result is like we're very close to perfect polar alignment, but it's still ongoing and I'm still not doing anything. And after a couple more iterations, we're down to like 5 arc seconds. What? Is that right? Yeah, 5 arc seconds or 7. Like when I'm moving, the balcony moves a bit with me because it's a big slab of wood. But yeah, we're very close to an insanely precise polar alignment, and I didn't have to do anything. I didn't even have to be on this balcony. I could be inside, just in warmth, drinking tea, something like that. And the mount, as you can tell, it polar aligned itself. So I'll show you how it works, where the motors are, and what is exactly this particular mount, what's going on, what is this, and how you can build one for yourself. So, this little mount, who are you who is so wise in the ways of science and of automatic polar alignment? Well, this is a very interesting mount. It's called the Open Astro Explorer, and it is a DIY, completely open source mount, meaning that pretty much everything you see here that isn't a screw or a motor or something like a metal part by necessity, it's a 3D printed plastic part. And it's all available online with detailed instructions on how you can print it, get the parts, and build it yourself. And this was sent to me by the guy who actually makes or basically makes, with the help of others, all of those designs, called Fabian from Open Astrotech. A few years ago, you may have noticed a mount that made waves online for a bit, which was the I think the Open Astro Tracker. It was a tracking mount, and it looked like really futuristic and crazy, with a design that was kind of like a crib for your camera, and the camera would rotate within the crib. It was kind of insane kind of design, and this is an evolution of that. And we can see some of the DNA here with the arches there on the side, which, by the way, are removable. And the counterweights, by the way, you may have noticed that they are not normal counterweights. They are dumbbell weights, which I bought specifically to be able to test this mount. So yeah, thank you to my Patreon supporters and child members for making the purchase of dumbbells for astrophotography possible. I love this. I absolutely love this channel and love this hobby. Anyway, yeah, so it's all 3D printed. It's all open. It's all for someone who is a tinkerer, who is not lazy, who likes DIY, who wants to understand all of the mechanisms of the mount. And you may have noticed that that's not me, definitely, because I am definitely Quiv the lazy geek. I am not mechanically inclined at all. So this has been a very interesting experience for me, even though they sent me the mount fully assembled in the first place. I mean, the only thing I had to do is place those side wings or arches there, put the belt on, tension it, and that was pretty much it. But overall, what you're seeing here is a full go-to mount controlled via ASCOM. It has a very competent ASCOM driver and the control center that you saw doing the polar alignment. And apparently, if you're going to build it yourself and print it yourself, the bill of materials for this is around 200 to 350 US dollars. So it is a cheap mount in terms of bill of materials, maybe not so cheap in terms of labor involved, although this labor is also going to be about learning stuff, and it is good for you overall. So you may not want to count it as a cost, but as a profit. Okay, so let's go a bit around this pretty incredible little DIY mount. And going from the front, you can see the wings that I was mentioning. This is the RA motor, and this is the RA belt going all around, and you can see it sticking out here around the wings, basically. You can tension it here, you can tension it there. It's a bit confusing. I was confused, but it worked out, so it's fine. It has a pretty interesting, I would call it a flaw, in that the belt stopper, what maintains the belt here is in those notches there. It's working fine, but I had one night where the belt here actually slipped until there was only one notch left, meaning if it had slipped completely, the whole assembly would have gone all the way down to the hard stop. The counterweights are actually slightly heavier than the setup that I have here, so you would not have gotten any catastrophe. It's just a pretty interesting potential point of failure. But the interesting part is when we go to the side, because to the side here, that is where we have the polar alignment with the azimuth motor here, and then you have a motor hidden in here for the altitude. And there are no knobs. Those two knobs on those sides here are basically just for you to secure the mount to one of the notches that we have here. One notch for each, latitude adjustment, like broad latitude adjustment that you may have to do. For me in Tokyo, with 36 degrees latitude, the second knob was the correct one. And if I go on the other side and I get to the controls part of the mount, we have standard stuff. We have the power input, which also doubles as a switch, and we have a USB-C to control it. One point that's very interesting with this mount, and that kind of like betrays its origins as an open astro tracker, is that the way that it's attached to the tripod is actually via an Arca Swiss plate at the base of the mount, and then there's this saddle, Arca Swiss saddle, that came with an adapter for an EQ type of tripod, and I'm using the carbon tripod for the Wave 150i mount from Skywatcher. And then at the top as well, if we look at the equipment, this is also an Arca Swiss plate, which has screwed in onto the foot of the SUF55 instead of a Vixen style plate. I honestly would have preferred Vixen style plates all around, but that's just me. The mount itself, by the way, is reasonably compact, especially since you can remove those wings, and those wings have magnets in them so that you can actually place them very easily before tensioning the belt around them. So that part of the operation was quite easy. One thing as well that's interesting with the automatic polar alignment is that you saw the fully automatic way of doing it. You can also send commands directly to the motors, and there's actually 5 speeds, and each speed will adjust by a certain number of steps, actually by a certain amount of degrees or arc degrees on the adjustment, which means that if I want to do the polar alignment manually without relying on the auto PA, I could see that, for instance, azimuth is off by 30 arc minutes, then I would actually send a command to the azimuth motor here to move by 1 step in speed 5, and that's exactly 30 arc minutes. So once you know the actual value in terms of angle of each step of the motor, it's also fairly easy to adjust your polar alignment from the comfort of your computer in the living room where it's nice and warm without having to be on your knees fiddling with knobs and that kind of stuff. Although I have to say, the first time I did it, I didn't know about the relationship between the motors and the actual angle that was there. I thought it would be like a normal slew on the mount where if I pressed long on an arrow, it would just like move the axis, azimuth or altitude more and more. No, it's just like one click is one amount depending on the speed that you have selected, and that actually makes it much easier and much more intuitive. The first time I really used it, I was like super frustrated. I'm like, give me back my knobs! But no, it's actually pretty much fine with the motors, and it's actually a lot of fun. And you would have seen from the start of the video, the polar alignment being done on its own is something that is absolutely insane. And why? Why is it that we have this on an open source mount and no large-scale manufacturer has provided us with automated polar alignment up to now, besides like the UPass system from Avalon? So with that, going back a bit into the open source aspect of this mount, what was very interesting is that whenever I mentioned an issue to Fabian, he's like I mentioned the belt issue there, where it could slip off if in some corner cases. And he's like, oh, okay, I'll look into it and I'll make an enhancement. That means that once he's done with his enhancement, I could go to my 3D printer, print the new part, and just use it. And then I have fixed my issue. And also one thing that is a huge drawback with this mount, and probably the main reason, or one of the reasons that I would not recommend it for a live production environment right now, unless you're a tinker, DIY guy, and you love that kind of stuff, is like it's super wobbly. I mean, look at that. I'm playing with just like the counterweights, or I could do it on the guide scope level, and yeah, it's super wobbly. Apparently, this is due to the automatic polar alignment base design. But Fabian is working on enhancing that so that it would no longer wobble. And so once that's available, you'll be able to print parts for it, make the wobble go away, and it works. So this is a mount that is alive not only in terms of software, so the control software for it, but also in terms of hardware. And you, as the end user, if you are somewhat technical, you're able to improve the software because open source, and you're also able to improve the hardware if you want to as well. Or just wait for Fabian to provide improvements. And that's a very good thing because, as I mentioned, as it is right now, I cannot recommend this mount for the common mortal man, right, or woman. But for a tinker, DIY guy, if you want to build your own mount for super cheap, this is pretty cool. Even though, for me at first, when I started to assemble it and use it, it was quite frustrating. One thing to note as well is that it is pretty sensitive to balance in terms of counterweight to telescope balance. And to check your balance, you actually need to completely remove the counterweights, remove the belts, so that the mount can rotate freely in right ascension, put back the counterweights, and then you can balance it properly. But to move the counterweights around, I have to use like Allen wrenches, and it takes a lot of time, and it's a pretty annoying thing. And for my setup, in the end, I decided to just add a more heavy guide scope so it would match my counterweights, with the counterweight still being slightly heavier. In case the belt slips, then that means the whole assembly would go back to home position kind of like automatically using the power and the magic of gravity. But yeah, it's a bit of a cumbersome process. The tensioning of the RA axis as well, I think it has like 3 screws where you can adjust the tension. I have no idea why. And I just screwed things in until like the little part here was tense and like kind of like the same amount of tension as I have in the belts of my 3D printer. And I called it a day, and it seems to be working fine. When there's no wind, the tracking accuracy on the mount was around like 0.7 arc seconds. So that was a good thing. By the way, also in the driver there, you cannot change the limits of the mount manually. There are kind of hard-coded limits in there. And if you wanted to, you could change them in the code and then compile your own version of the driver. But it kind of makes sense because this mount, I think, is up to 5 kilograms of payload. And with 5 kilograms of payload, you'll have a small telescope on top. So you probably do not need like hardware limits of the mounts that are different than the base ones that are hard-coded in the drivers. But yeah, again, overall, I would not recommend this mount, especially if like you're a beginner or you are used to very good mounts from various manufacturers. But this opinion might very well change with time. If I replace this Arca Swiss saddle, which, you know, I can do it myself. I can find a Vixen type saddle there with a Vixen type saddle. That will be good already. If I change the fixing mechanism at the base of the mount to the tripod with something a bit better for my taste, I could start recommending it even more. Once this little part here, the tensioner that's also stopping the belt from slipping, is redesigned, I could start recommending the mount even more. Once the base for the polar alignment is redesigned so we don't have that annoying wobble here, I could start recommending even more. And all of this is possible because of open source. So I'll show you on the screen, by the way, some guide charts. So here is a guide chart without wind. Everything is beautiful. There's no issue. Everything works. We're all good. Now this is a guide chart with a bit of wind. You can see we have some deck excursions. Yeah, I think that's the wind. And this is a guide chart with more wind. And yeah, all hell break loose. It's not great. And of course, my balcony here in Tokyo tends to be very windy. So this is really not the mount for me. By the way, there's one more thing that is available from Open Astrotech, and it's this guy here. This is a fully integrated guider that has guide scope. It has guide sensor integrated. It's the 290. It has a dew heater integrated with a switch at the bottom here to turn it off or on. And it's controlled via a single USB-C port. You can use it. I tested it with SharpCap and with PhD2, and it's only $100 roughly, which means that I think it's pretty much an unbeatable value on the market, like fully integrated guide scope, sensor, dew heater, all in one. Pretty amazing. And when I first used it, I promptly broke it. So I had to actually reassemble it. And I followed the instructions on the Open Astrotech website for the initial assembly, and that actually helped me really get the focus down, and everything was working as I used it, and it worked beautifully. So I would say the biggest drawback is that you really need to check the manual, like even the assembly manual out before using it to make sure that you know how to use this focus properly. And also another issue has been the mounting system for the saddle, and only guide saddles that are open on both sides are able to support this. Like something like the saddle of the SQF55 that's only open on one side is not going to work with this. But Fabien is already aware of the issue, and he's already working on designing a new system for the saddle mounting. So it probably is going to get fixed because this is also open source, and therefore it is also alive and always getting better. By the way, I wasn't able to test the dew heater part because I broke it immediately, and completely user error. It's my fault. But anyway, in Tokyo, I don't really have a lot of dew on my rooftop with so much wind. But I don't see why it wouldn't work. So this is pretty cool. By the way, I'll put all of the links down in the description if you're interested in building your own mount, building your own guider, I guess, as well. I'm not even sure whether Fabien sells kits so that you can assemble. You don't need to 3D print anything, and you have all of the parts and you can assemble it yourself. Or whether, like he did for me, he provides like pre-assembled versions. Actually, I have no idea as I'm filming this, but I'll have all of the details down in the descriptions. Now, otherwise, in terms of the mount itself, I've already said I cannot recommend it as it is right now. Besides that, it's absolutely amazing that we have an open source mount like that that's fully go-to with automatic polar alignment. And it did the meridian flip perfectly fine for me, from Nina. Nina did report an error after doing the flip and trying to recenter the object, but 60 seconds later it recentered it fine, so it wasn't really an issue at all. This has a lot of potential. So if you're interested, have a look at least at the links that I have down below. I think it's a fascinating project. And if you have any leverage with makers like ZW, Ioptron, etc., let them know about this, because it would be awesome to have automatic polar alignments on mounts, so that we don't have to kneel down and we can just run the 3-point polar alignment and Nina, and the mount does the rest. How amazing is that? With that, let me know your thoughts down in the comments. Like the video while you're at it. It really helps the channel out. And if you want to support me even more and you're planning on buying anything from Gina, High Point Scientific, even Amazon, even if it has nothing to do with astrophotography, if you do so after clicking one of the links that I have down in the description or the pinned comment, it will help me out at no cost to you. If you want to sponsor the channel directly, you can become a channel member. It's the join button next to the subscribe button, or a Patreon member. The link is down in the description for Patreon. Some of my Patreon ranks have access to my videos early and without ads. All of them have access to a Discord server. With that, again, I would love to hear your thoughts down in the comments. Thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.